Hello. Today we're going to continue on with our simplifying of radical expressions, but today our lesson is going to include those expressions that have quotients. All right. So if you remember, the rules of simplifying radical expressions were these three things here. It was no perfect square factors other than one in the radicand. We've been using that quite a bit whenever we were simplifying our expressions before in the past two lessons. Now that we have quotients involved with our radical expressions, now we have to also look at these two rules and make sure that we are following them as well. The first one is no fractions are allowed in the radicand, remembering that's the number that's underneath the square root sign. So we can't have something like this, the square root of 1/2. Okay, that's not allowed. And no radicals appear in the denominator of a fraction. So for instance, we can't have this 1 divided by the square root of 2. That's not allowed either. So today what we're going to do is we're going to learn how we can get rid of or how we can simplify those two items as well. Okay? Basically what we're doing is we are doing something that's called the quotient property of radicals to eliminate fractions in the radicand. Okay? This is very similar to the one that we used for multiplication because what we're saying is if we have the square root of a fraction, it's the same as saying the square root of the numerator divided by the square root of the denominator. So for instance, if I had the square root of, I don't know, 4 over 25, that would be the same as saying the square root of 4 divided by the square root of 25, which then everybody knows the square root of 4 is 2, and then the square root of 25 is 5. So there you go. We could simplify that square root of 4 over 25 to 2 over 5. Okay? So with that knowledge, what I would like you to do is try letters A and B, and then check your work with mine. All right, with letter A, the square root of 9 over 16 would be the same as the square root of 9 divided by the square root of 16, the square root of 9 being 3, and the square root of 16 being 4. So that would simplify to 3/4. All right, in letter B, square root of 1/9 is the same as saying the square root of 1 divided by the square root of 9. Everybody knows the square root of 1 is 1, and the square root of 9 is 3. So there you go. We have that being simplified to 1/3. Everybody try letters C and D and then check your work with mine. All right, with letter C, the square root of 13 over 100 would be the square root of 13 divided by the square root of 100, which would be the square root of 13 over 10. Now, notice that this one still has a square root sign in it, but that square root sign is in the numerator, so we're all good. Because remember, no radicals can appear in the denominator of the fraction. It's okay if they're in the numerator, but we can't have them in the denominator. All right? And then the last one, we have the square root of 7 over x squared is the same as saying the square root of 7 divided by the square root of x squared, knowing that I can't take the square root of 7. Well, I can, but it would just be a decimal that goes on forever and never repeats. And then here, the square root of x squared is x. Once again, it's okay to have a square root in the numerator, but since I don't have one in the denominator, that's the most simplest form I can be. So all of these resulted in things that did not have square roots in the denominator. But there are times when our simplification process has a square root in the denominator and we have to get rid of it. And so to do that, on the next page, you'll see we have to simplify it even more by doing something called rationalizing the denominator. So, say for instance, I had this thing right here, the 5 divided by the square root of 7. Okay, I'm going to just redo the problem over here. 5 divided by the square root of 7. I can't have this in the denominator, the square root of 7 in the denominator. So I have to get rid of it. But knowing that the square root of anything, say for instance 2, times the square root of the same thing is just going to result in that thing that's underneath the square root sign, because the square root of 2 times the square root of 2 is the square root of 4, and then the square root of 4 is 2. What I would like to do is just take this and multiply it by the square root of 7, because then I'll get rid of the square root of 7 on the denominator. However, I have to have an equivalent fraction that I'm multiplying my original fraction by, so I can't just multiply it by the square root of 7. I have to multiply it by 1. So to make that into 1, I'm going to have the square root of 7 divided by the square root of 7. Notice that this fraction right here is 1. 1 times anything is itself. So this fraction will remain the same because I'm multiplying it by 1. But when I do that multiplication, this is going to end up being 5 times the square root of 7 divided by the square root of 49. Because 7 times 7 is 49. They're both underneath the radical sign, so it's the square root of 49. And we all know that the square root of 49 is 7. So what do you know? We got rid of the square root of 7 in the denominator. And here, what we have to do is just keep it like this, 5 times the square root of 7. Once again, it's okay to have a square root in the numerator, just not in the denominator. All right, so let's look at letter A. Let's try to simplify that. It has 1 divided by the square root of 3. Can't have that square root of 3 in the denominator, so I would have to multiply this by the square root of 3. Notice that these are the same thing. That's how you can figure out what to multiply by. But I have to multiply the whole thing by a 1, so that's why it's the square root of 3 divided by the square root of 3. When I do that, it's going to end up being the square root of 3 divided by the square root of 9, which ends up being the square root of 3 divided by 3. That is my final simplification of 1 over the square root of 3. You will be using this a lot in geometry, and so that's why we have to make sure we go through this. All right, tell you what, everybody try letter B and then check your work with mine. Everybody should recognize that we have the square root of x in the denominator, so we have to multiply that by the square root of x, but we're going to multiply the whole thing by 1, so it's the square root of x divided by the square root of x, ending with the square root of x divided by x. All right? Everybody check out letter C, then check your work with mine. All right, everybody should have recognized that in the denominator we have the square root of 2x, so I'm going to multiply it by the square root of 2x divided by the square root of 2x, ultimately coming to x times the square root of 6 divided by 2x, but then you have to say, oh, those x's will simplify, so it's going to end up being the square root of 6 divided by 2. Another way that you could have approached this was like this, recognizing that as the square root of something divided by the square root of something, I could have put it back together as this, the square root of 3x divided by 2x. Then you can see, oh, those x's will simplify there as well, so it's the same as saying the square root of 3 over 2, and then split it back up to be the square root of 3 divided by the square root of 2, and then multiply by the square root of 2 over 2. What do you know? You still get the square root of 6 over 2. All right, either way will work. Okay, let's look at letter D, and then check your work with mine. All right, everybody should recognize that we need to multiply by the square root of 3b divided by the square root of 3b, because that is 1. Ending with then resulting in the square root of 6b divided by the square root of 9b squared. And then that can simplify to the square root of 6b divided by 3b. Awesome. Let's look at the next one. Letter E. Check your work with mine. All right, everybody should recognize that we could split this up into parts as being the square root of 100 divided by the square root of 4x squared. Then say, oh, I know the square root of 100, it's 10. Oh, I know the square root of 4x squared, it's 2x. But then recognize, oh, I have a 10 divided by 2. That'll further simplify to 5. And so it's going to be 5 over x. Another way to have approached this one as well was to simplify at the beginning here. We have 100 divided by 4. That's the same as saying the square root of 25 over x squared. What do you know? That's the square root of 25 over the square root of x squared, and which would be the square root, oh, not the square root. Square root of 25 is 5, and the square root of x squared is x. So you're going to end up with the same answer either way you go. All right. Letter F. Everybody try it, then check your work with mine. All right, splitting this up into the parts, I have the square root of a cubed divided by the square root of 21. Then I should say, oh, the square root of 121 is 11, so I got the denominator done already. But the square root of a to the third, I can split up to the square root of a squared times the square root of a, and then I can say, yeah, that's the same as a times the square root of a divided by 11. All right. So now you have all the knowledge that you need to be able to simplify uh, radical expressions when they have quotients, including when you have to rationalize your denominator. So, bye.